Hello, today we're going to be exploring a little bit with logarithmic form. This should be reviewed from earlier in the school year. Most of what we are doing today is just writing things in one format to the other, so there's not a lot of calculation involved, more so rearranging. These first two, sort of like when we rewrote exponents as radical form, we are rewriting exponential expressions in log form or the other way around. Key thing we want to know, need to know for these first two here is how we switch from one form to another. If we want to have things written in log form, first we write the word log, and then we rearrange our exponent expression like so. The base goes into the base of the log here. Whatever was the answer before becomes the argument, and whatever was the exponent becomes what the expression is equal to. So if I want to take 7 to the third equals 343 and write it in log form, I write the word log, which I always do in cursive. You don't have to, it's just what I always do. And then I put my base, which was 7. What used to be my answer, it becomes the argument, so 343 equals the only number we haven't used yet, which was the exponent, 3. So another way of writing this in a different form is what I have here in green, the log form. These two things are just different ways of writing the same thing. If I want to go the other direction, if I have a log, I can write it in exponent form by kind of just doing the opposite of what we just did. So we don't write log anymore, we're in exponent form. Whatever the base of the log becomes the base of our exponent expression. Whatever used to be in the after the equal sign becomes the exponent, so 0. And whatever used to be what we call argument here becomes what it's equal to. And you end up with something that is true that you can double check with your calculator. If you do 6 to the 0 power, you do get 1. So we end up with a true equation. Just a different way of writing what we had there to start with in blue. The next two are evaluating logs. So we need to come up with what this would be equal to. How do we figure out what this was equal to? It might be easier if you think of this in exponent form. So instead of writing log base 3 of 27 equals something, I can think base 3 to the we don't know power, that's what it will be equal to, equals the argument. So what exponent would I need to put on 3 to get to 27? If you think about your powers of 3, 3 to the third power is 27, so if I evaluate this log base 3 of 27 equals 3. So our answer here is just 3. Same idea for the next one, log base 5 of 25, what does that equal? Let's think about it as an exponent. Base 5 to the something, which is what we're trying to find, equals 25. What exponent do I have to put on 5 to get to 25? 5 squared is 25, so log base 5 of 25 equals 2. If I evaluate that log, I get 2. The last things we're going to do here are expand and condense some logs, which uses what I have here in purple. Once again, I do have log written in cursive, but you don't have to write it. It's just, I'll just show you here real quick. If I write log in print, it looks like a 1 or a 10 here, and that gets really confusing. So that's why I do cursive. Anywho, what you are doing here when you're expanding or condensing, so you're just taking one side of these property equations and switching it to the other format. So to start here, I have log base 5 of x times y. One of my properties, this top one here, says if I have multiplication of a log, that's the same as doing log base b of the first argument plus log base b of the second argument. Notice that you are writing that log twice, which is where that expanding. You're starting into something that's longer. So I'm just going to convert this to an addition by following the equation I have here. So if I have log base 5, I do log base 5 of my first argument, which is x, plus, then I write log again, my base is 5, and then my second argument, y. So all I'm doing is switching from one format to another. Nothing too crazy there. Next one involves division. Division can be rewritten as subtraction, so I'm going to follow the format here. Once again, we see that we start with our log. Base this time is 7, so log base 7 of the top argument minus log base 7 of the bottom argument, which is y. The last property here says if I am doing the log of something with an exponent on it, I can rewrite it or expand it by switching the exponent into a coefficient. So what that just means here is this exponent 3 becomes a coefficient 3 in front, and then everything else stays the same. So log base 9 of a to the third is the same as 3 times log base 9 of a. I almost forgot my base. These ones we're condensing, we're just going the opposite direction. We're taking things that are on this side of the equation and switching them back into the more compact form. So I'm starting with addition. Addition can be turned into multiplication. So let's try that. Log base 4 of x plus log base 4 of y is the same as log base 4. Notice we're only writing it once. And then we're multiplying the arguments together. X times y. Next one has subtraction. Subtraction turns into division. When we turn it to division, we only write our log once. This time my base is 5. And then I do my arguments as a fraction, top, bottom. So x over y. Last but not least, I have a number in front. A coefficient in front becomes an exponent. So this 4 here is going to become an exponent 4 instead. When it becomes an exponent, we write log first, then our base, which here is 9, x, and then this becomes exponent 4 on that x. So again, nothing too crazy here, mostly just rewriting things from one format to another. That is it for today. Have a wonderful day.